Hi, you were looking at InfoSewer's InfoSewer program, and we're going to discuss steady state models and what variables you see in the model. So again, with steady state, you run it as a steady state option. Here's our steady state option. It does not do any time values at all. It just gives you the peak values. So we will go ahead and run it. As usual, it always runs really fast. And in the past, I've done basically we're looking at the peak flow. The peak flow as a map display. So apply that, and as you can see, the colors and the size of the link change as the flows change. Okay, so if we look over here, here's the basis of the program. We have loading manholes. These are the green things, and we're using a peakable base flow. And it'll tell us what the base flow was and what the peakable flow is. The peakable flow is defined under peaking factor. So you basically have peakable loads. You have a peaking factor load and a peaking factor exponent. So it takes the base flow and routes that peaking flow throughout the system. You can also have an alternative peaking factor, or you can do peaking as a function of coverage, which is population. And also in each link, if you look at the output, and the output is shown in the attribute browser, we have a total flow, which is our peakable flow. No unpeakable flow. Coverage flow, we also have infiltration. Infiltration is defined in a link as two things. It's either pipe diameter length, pipe surface area, count-based, or pattern-based. There's a lot of flexibility inside of InfoSewer. Now, what the important things you want to look at are D over D, which is the depth of water over the total diameter, Q over Q, which is the flow of the water over the full Manning's equation flow, so that's Q full. The water depth, the critical depth happens when you have a Froude number of 1. And here's the Froude number. So this is the critical depth if the Froude number was 1. Here's our full flow. It tells us that there's backwater, and this is kind of key to understanding this output. Our D over D is 0.14. We have backwater. So what does this mean? How does it how does that impact the solution inside of InfoSewer? Well, it adjusts the depth. So when you're looking at the worst condition, you always want to look at the adjusted depth, because the adjusted depth tells you what the flow D over D was at the beginning, and then the second step affect the backwater or pressure flow. So adjusted D over D gives us our worst scenario, or worst condition. So that's a little bit about InfoSewer Steady State. I'm Bob Dickinson from InnoVice, and thank you for listening.